Hello, hello, hello. So, this is a very another K-bar question. Maybe you're at maths. So, it's about quadratic function, but it just like between quadratic equation and quadratic function. So, x is randomly chosen between negative 100 and 100. So, well, what is the range between the x first? We can actually get r, the range of x, okay, equals to 100, the large one minus the small one. You will get 200. Okay, so the question is, what is the probability of a g f x is negative, given that fx is something something and then gx is something something? So, what is meant by the composite function g f x is when you substitute the fx in gx. So the x, you will have fx in, and then minus 2 fx, and then minus 99. Okay, this is called the fx composite function. But let's say for simplicity, we let, okay, we do the u subs, u equals to the fx first. Okay, so it becomes u squared minus 2 minus 99. Okay, sorry, minus 2u. Okay, it's this equation. So, and you will later you will see the purpose of why I do so. Well, in order to know what is meant by if g f x is negative, it means in terms of graph, you will have a composite function, okay, the graph of the composite function g of x against x. And when you plot the graph, what would you expect? What is the function that you would have? Well, because you composite the gx with fx, you will have this, the square with this equation in, because of, well, fx in the square. So you will have to expand and then you will get the highest degree. Okay, so if you have a composite function, like let's say you have a from x and then b from x, so the highest degree for a is let's say m, and then the highest degree for b is n. What is the degree, highest degree of abx? You will have m plus n. Same goes to this concept. If your fx has a highest degree of 2 and gx has a highest degree of 2, then gfx or fgx will have the highest degree of 2 plus 2, which is equals to 4. So you must have a quartic curve. So a quartic curve is expected to be something like this. Something like you have a curve, U shape, and then y-intercept, and then you have back the curve like this. Sometimes you might have something like this, touches the point. Okay, this is tangent, and then again intercept back, and then maybe touch again like this. And then sometimes you will have something maybe on the other side, like reflection of it, or maybe they do not intersect the x-axis at all, depending on the quartic function you might have. So how are we gonna know whether or not we have 4 or just only 2 intersection, 1 tangent? Okay, in this case, so we're gonna try to use this gfx in terms of u. Okay, we recall back, gfx is gu because we said that u equals to fx, so gu, okay, is correct. So it equals to u squared minus 2u minus 99. So first and foremost, we want to find when gu equals to 0, what you will get. Yes, you will try to factorize it, and Well, when you factorize it, you might use your calculator to get the quadratic formula or so on. You will get u equals to 11 or u equals to -9, and hence we recall back again. Okay, u equals to fx, so we can actually use back the fx, which is x squared plus 3x minus 7 equals to 11, or the same thing, just copy paste down. Okay, equals to -9. So you will just have to use the quadratic equation again, and then you will get this here, x equals to 3 or x equals to -6, and then hence you will use it to repeat the same step for the second equation, which is this equals to 9, and you will get x equals to -1 or x equals to -2. Oh, interestingly, we have, well, these equations, and we can actually try to solve for them. Okay, we can actually try to get these 4 x-intercepts, the first and the second and the third and then the last one. So what does it mean? That the curve itself, which is this well, gfx, okay, oh my terrible thing, gfx, okay, against x we have a curve of 4 x-intercepts here, okay, for example, and then you will be able to solve this question like very randomly. Sorry, it might be logically like so. This is much better. We have 3. We have -1, -2, and then, well, -6. So why did I actually find the range of x, which is this one? Because the question actually says we must have a probability. The probability of getting the g of x is negative is when your probability, your x, your function, okay, we try to denote again that g of x, where the composite function, okay, is less than 0 or negative. Let's say we use g of x as a capital Fx. So the probability of when the fx is less than 0, it equals to the first range of x over the total range of x plus the second range of x over the total range of x. So recall back, the total range of x equals to 200. What is the first range of x? Well, the first range of x is just like this. You just have to look at the x-intercepts here and here. So you will get -2, and then -6, you will get 4. And the second range, you will do the same thing for, in this case, -1 and 3. So equals to 3 minus -1 equals to 4. And, well, if you do the fraction, if you manipulate it a bit, you will get this in total. You will get this over 200. You will get this 8 over 200, which eventually it brings you the simplified expression of 1 over 25 QED. Well, it seems a very complicated question, but it doesn't really matter, okay? That you don't have to make yourself to learn very complicated analysis, but it's just a very trivial use of finding the x-intercept and the use of an x-intercept, okay? so that you can get the probability when g of x is negative. The most important thing is the sentence of when g of x is negative, which means when g of x is less than 0. When it's less than 0, the curve will be downward. So at which value of x, like -6, between -6 and -2, the range between the -6 and -2 will have a, well, we have the x here, I mean the g of x here, negative. Same goes to when the x is between -1 and 3, you will have a negative here too because it's below the x-axis, okay? And hence you will calculate the probability by getting the range r, capital Rx, and the small r1 and the small r2. And you will get the final answer 1/25, and that's all.